Okay, so your corresponding angles are always congruent, and they're in the same position, okay, across your transversal and your parallel lines. Okay. Questions on the corresponding angle postulate? Okay, the next one is what we call a conjecture. Okay, a conjecture is a hypothesis that something is true. It later can be proven or disproven. Okay, and we're going to get into that a little bit more in our notes. There's nothing that you need to put in the real world drawing or the notation box. Okay, our next one is alternate interior angle theorem. Alternate interior angle theorem. Okay, if two parallel lines are intersected by a transversal, then alternate interior angles are congruent. Okay, again, draw your parallel lines split by or intersected by your transversal. Number them, same thing as last time. Okay. Alternate interior angles are congruent. So I want you to draw, or with a highlighter, whatever you have. Let me get a color that will work. I want you to draw a Z. Okay, for every set of 8 angles here, okay, we have 2 sets of alternate interior angles that are congruent. Okay, they are alternate sides of your transversal. So alternate sides of your transversal, that's why the alternate part's there. Interior means in between your parallel lines. So alternate sides of your transversal in between your parallel lines. So which ones are alternate interior angles? Very good. So angle 3 is congruent to angle 6. Oops. And angle 4 is congruent to angle 5. Okay, if you draw your little Z, okay, on your parallel lines with your transversal, it's the angle that your little highlighted part eats. Okay, so notice how it's in between your little Z. Okay, so this little angle right here and this angle, okay, you almost highlighted them. And then if you were to flip your Z on backwards, it would highlight 4 and 5. Any questions about alternate interior? So alternate is on opposite sides of your transversal, interior between your 2 parallel lines. Okay, then our next one is going to be alternate exterior angles. Okay, alternate exterior angle theorem. Very similar. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Okay, draw your same little diagram. One, two, three, four. Okay, so alternate means what? Opposite sides of the transversal. What do you think exterior means? Outside of your parallel line. So alternate exterior angle theorem. So what do you think is one pair of alternate exterior angles? 1 and 8 and 2 and 7. Okay, so it has to be alternate sides of the transversal and outside of your two parallel lines. Okay, so far we've done alternate interior, alternate exterior. They are congruent angles. Okay, so your alternate interior and alternate exterior angles are congruent. Questions? Okay, next one. I think we only have 2 more. Yes, 2 more. Same side interior angle theorem. So same side interior angle theorem. Okay, very similar. If two parallel lines are cut by a transversal, then the pair of same side interior angles are supplementary. Little change up there. Not congruent. They are supplementary. Okay, the way I remember the difference. Okay, same side SS supplementary. Okay, so same side supplementary. Okay, so this time we have same side interior angle theorem. Draw your same little diagram. Okay, what do you think same side means? Same side of the transversal. Okay, interior. Inside the parallel line. So we're same side of the transversal and same side of the parallel line. So give me a pair. 3 and 5 or? Oh. Supplementary. So they should say measures. It's a little m. Measure of angle 3 plus the measure of angle 5 equals 180. And the measure of angle 4 plus the measure of angle 6 equals 180. Okay. Tell me a pair of angles that are corresponding. 1 and 5. 2 and 6. 3 and 7. 4 and 8. Sweet. Give me alternate interior. Don't look. Just look at the picture up here. 3 and 6 and 4 and 5. Very good. Same side interior. Okay, same side interior angles are Supplementary. Alternate interior angles are congruent. Alternate exterior angles are congruent. Very good. Okay, the reason why these are supplementary, okay, so let's look at 3 and 5. Okay, angle 5 is also congruent to what? Angle 1, why?
Because they're corresponding.
Because they're corresponding. Angle 5 is also congruent to what?
Angle 4.
Angle 4 because of?
Interior.
Alternate interior angles. Angle 5 is also congruent to what?
Angle 8.
Angle 8, why? Vertical angles. Okay, so let's go way back to my first question. Okay, 5 is congruent to 1, right? Okay, we said 5 and 3 are supplementary, and that makes sense. If 5 is the same measure as angle 1, we know that 1 and 3 are a linear pair. Okay, they have to be 180 degrees. That's why we can say that 3 and 5 are also supplementary. Does that make sense? Okay. Last vocab word. Same side, exterior. Okay, same side exterior angle theorem. If two parallel lines are cut by a transversal, then the pair of same side exterior angles are congruent. Okay, let's draw our lines. Oops, those aren't very parallel. Okay, so again, same side, supplementary. Oh, that's why. Whoops, sorry, got carried away. This should say supplementary. Sorry about that. Nobody stopped me. No, my bad. Okay, so same side, supplementary. All of them again start with S, so it's an easy way to remember. Okay, same side means what? On one side of the transversal. Exterior means outside of the parallel line. So give me a pair that are supplementary.
1 and 7.
1 and 7. What's another one?
2 and 8.
Very good. So 1 and 7, 2 and 8. Okay, so you don't have any more vocab quizzes. However, this is going to be important in order to do the proofs that we have coming, okay? So, again, you are responsible for all this vocab. If you don't know your vocab, it's going to be really hard to fill out the proofs. Got that? Okay. On to the notes. You need a protractor. Okay, with your groups, I'm going to give you 10 minutes to do this warm-up because you have to measure all of those angles. Okay? Shh. Chances are your protractor is too big to measure these angles when they're this small. Guys, okay, in order to be successful, you're probably going to have to extend all of your lines so that your protractor will reach. Okay, but I want you to measure all of these 8 angles and all of these 8 angles. However, okay, these lines are parallel. Okay, so use some of those rules you just found. Essentially, how many angles do you really need to find? 1. As long as you have 1 angle, you know it's supplementary. You know it's vertical angle. You know it's corresponding, and then you can do the same thing. So you need to find 1 here, and then down here, since they're not parallel, you actually have to find them all. except for your vertical angles, but all the rest of them are fine. So this shouldn't probably even take you 10 minutes because essentially you only have to find, I think, 3 angles. And then answer question number 3. Alright, let's come back. So angle 1 was 135 degrees. You guys told me. Okay, angle 2 is how many degrees? 45. How do we know angle 2 is 45 degrees? Very good. That's a linear pair. That means it's supplementary and it has to be equal to 180. Okay? 1 and 3 have what kind of relationship? They are vertical angles, and vertical angles are always congruent. So angle 3 is what? 135 degrees. Making angle 4 what? Okay, angle 1 and 8 are called what? Corresponding angles. And corresponding angles are congruent, making angle 8 what? 135, and then the cycle just repeats itself. Okay, if you were off on your measurement and you had 134 or 136, as long as you know the relationships and have 1 and 3 and 8 and 6 all congruent, it's okay. Okay, number 2, angle 1 was what?
137.
Okay, we'll go 138 in the middle. Okay, which made angle 2 what? 42. Okay, if you're a little off, it's okay. Okay, 2 and 3 are called what? Vertical angles, and vertical angles are congruent. Okay, angle 5 is what? 115, sure. 6, 7, and 8. Very good. Okay, so the big idea for number 1 is that it was the parallel lines cut by the transversal, so it was all those terms that we just learned. Okay, and then for number 2, the only really big idea here is the vertical angles are congruent, and then you have a bunch of linear pairs, so they should all be, linear pairs should always be what? Supplementary. Very good. So they always should add up to 180. Okay. Question 3. What are the similarities and differences you notice in the 2 tables above? I didn't fill out my tables, but what did you guys put down? Okay, yes, they both had 8 angles. What else? The first one, there was only 2 numbers, right? So 1, 3, 6, and 8 were all congruent. 2, 4, 5, and 7 were all congruent. And then what happened on the bottom? Very good. So there was 4 sets of congruent angles instead of just 2. Awesome. Okay. We're going to fly through these next parts because we already filled out our vocab sheet. So you guys fill in the blank as I say it aloud. If 2 parallel lines are cut by a transversal, then the pair of corresponding angles are congruent. I want you to take your marker, highlighter, pen, whatever you have, and mark a set of corresponding angles. Then take a different color and mark another set. And then a different color and mark a third set. And then the 4th and final set. If you don't have 4 colors, it's okay. You can just mark 2. So you have 1 and 5, 3 and 7, 4 and 6, and 2 and 6. Oh, sorry, 4 and 8, 2 and 6. Yeah.
I have a question. It might be a dumb question.
There's
but,
no dumb question.
It doesn't have to be like 1, 2, 3, 4, 5, 6, 7.
No, it could be like 11, 12, 13, 14.
And it doesn't have to be
A, B,
orders,
C,
so it could be
D.
like 1, 5. Okay, yes.
Okay. Next one. Alternate interior angles. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. With your markers, mark your alternate interior angles. What are our two pairs? 3 and 6 and 1 and 4.
Oh, sorry, 4 and 5.
4 and 5, yes, 4 and 5. Okay, so alternate means what?
Opposite side.
Opposite sides of the transversal. Interior means
Inside of the parallel line.
inside of your parallel lines. Awesome. Okay, alternate exterior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Okay, mark your alternate exterior angles. Somebody give me one pair. 1 and 8. Somebody give me the other pair. 2 and 7. Okay, same side interior angles. If two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. Good job. If you want to highlight your S's, you can. Same side supplementary. Okay, give me a pair of same side supplementary. 3 and 5, and what's another one? 4 and 6. Questions? Okay, last one, same side exterior angles. If two parallel lines are cut by transversal, then the pairs of same side exterior angles are supplementary. Oops. You can highlight your S's if you need to. Somebody give me one pair. 1 and 7, and my other pair. Same side supplementary. Okay, questions on our, what was it, 5 new terms? 5 new terms? Anything? Okay, let's look at the practice. If lines C and D are parallel and cut by a transversal line A, okay, then the angle measure of 65 degrees is congruent to which of the following angles and why? Okay, so we know that these angles are parallel and they're cut by this transversal A. Okay, somebody raise their hand and give me one angle that is congruent to 65. Raise your hand. Yeah, Monica.
G, because alternate exterior.
Very good. G because of alternate exterior. Cliff, give me one. F because of corresponding. And somebody give me the last one. Yes.
E because vertical.
E because of vertical. Questions on that?
Is there more than that?
What do you mean?
Like another associated
J would be what? This is a good talking point. What would J be? Why would J be 65?
Because it's corresponding to
Okay, it is corresponding to E. Very good. Okay, the only reason that it is not is because it does not say that lines A and B are parallel. Okay, so do not make the assumption. Okay, The only lines it tells us are parallel were C and D. Okay, so we cannot assume that A and B are parallel. But good job. If they were parallel, then yes, that would have been exactly right. Questions? Okay, next part. Okay, number 1, we have x squared and 3x. What kind of angles do I have here? Same side what? Interior. So I have same side interior. What do I know about same side interior angles? They're supplementary. Okay, so x squared plus 3x equals 180. Okay, back from our good old algebra. Okay, in our algebra quiz. How do we factor this? What's the first thing we have to do? Set it equal to 0. So we have x squared plus 3x minus 180 equals 0. Okay, so I need to look for my factors of 180 that are going to possibly give me 3. Okay, and I know I want a negative 180, but I'll worry about that in a second. Okay, with your calculator, start going. You have 1 times 180. 2 times 90. 3 times 3. Does 4 go in? 5.
Yes,
4 does go? 45. 5.
36.
6.
30.
7.
No. It doesn't go.
8.
No. 10.
Does 8 go?
8. No.
9.
20.
10.
18.
11.
No.
12.
15.
12 and 15. Ooh. There we go. So do you see how that difference is 3 right there? Okay, so in order to get a positive 3, but I need a negative 180, which one am I going to negate?
12.
Negative 12. Okay, and then we'll have a positive 15 so that I can get that positive 3. Okay, so I have x minus 12, x plus 15 equals 0. So what are my possible values for x?
12 and 18.
Okay, just like with our segments, can you have a negative angle? No. Okay, so you need to see which one works and which one does not. Okay, when I plug in 12 here, I'm going to get what?
12 squared, 144.
When I plug in 12 times 3, 36. Either one of those negative? No, so we're good to go on that one. Negative 15 squared is what? 225. Negative 15 times 3? So does that work? No. So our only answer is x equals 12. Okay, so always make sure you go back and double check when you have two x equals or two solutions. Okay, number 2. Okay, we have 135 and 2x plus 15. What kind of angles do we have? Corresponding. Okay, corresponding angles are congruent. So how would you solve for x in this case? Set them equal to each other. 2x plus 15 equals 135. What's my first step in solving this? Subtract 15. So I have 2x equals 120. So what does x equal? Very good. Questions on 1 or 2? Okay, that's the kind of application that you're going to be doing. So, for example, if you didn't know that those were corresponding, you wouldn't be able to solve the problem. If you didn't know corresponding angles were congruent, you wouldn't be able to solve the problem. Okay, that's how important vocabulary is with for geometry. Okay, so make sure that we're going home and studying that vocab. Questions on 1 or 2? Okay. Number 3. Good a proof. Okay, use a two-column proof to prove the alternate exterior angle theorem. In your proof, use the following information to, I don't know what that's supposed to say, to and the picture shown. use the following information. I'm going to guess it should say and the picture shown. Okay. Given R is parallel, this should have an S. R is parallel to S. T is a transversal. Prove angle 4 is congruent to angle 5. Okay, number 1 says R is parallel to S. Okay, that's already marked with these arrows. And it says T is a transversal. Okay, so what's the reason for number 1? Given. Okay, based off my second reason, I have corresponding angles postulate, so I need a pair of corresponding angles that are congruent. Okay, we want to go in the direction that our proof is going, so we want to make sure we include angle 4. 2 and 4? Okay. Angle 2 is congruent to angle 4. So I'll mark those congruent. Okay, then what do we know? Angle 2 is also congruent to what? Angle 5. How? Vertical angles. Okay, so now that last step says angle 4 is congruent to angle 5, and how'd you do that? Is there operations? No, so it is transitive. Very good. Okay, there would have been multiple ways to solve this. Okay, it just used angle 4 and angle 5. Okay, so if you did it in more steps, you would probably still arrive at the same solution, but I kind of probed you along so that we could do it in 4 steps. Yes.
So like, when it said that R is parallel to S and then T is transversal, can we directly not say that 5 and 4 are like congruent because they are alternating angles?
Yes, but that's what we're trying to prove.
Oh.
So we couldn't say that because we're proving that that theorem works. Questions? Okay, so that was it for the notes.